Covering Geometry with Mrs. Berry. This is lesson 64. In this lesson, we will talk about volume and the volume formulas for pyramids and cones. There is a simple relationship between the volume of a prism and pyramid with congruent bases and heights, as well as a relationship between cylinders and cones with the same bases and heights. The best way to investigate this relationship is with geometric containers of these shapes. If you happen to have some geometric containers, fill a pyramid with water or sand and then pour the contents into the prism. So you're looking for a pyramid and a prism that have the same base and the same height. When you pour those contents in the prism, about what fraction of the prism is filled by the volume of one pyramid? You can check your answer by continuing to repeat until the prism is full. How many pyramids filled one prism? You can do the same thing with a cone and a cylinder that have the same base and height. Fill the cone with water or sand, then pour the contents into the cylinder. About what fraction of the cylinder is filled? Check your answer by repeating until the cylinder is full. Here is a rectangular prism and a rectangular pyramid of the same height. Watch what happens when we fill the pyramid. How much of that do you think it is? Let's check by doing 3. 3 pyramids fill that prism. You can see it again. 3 pyramids fill that prism. Now we have a cylinder and a cone. They have the same circle base and the same height. How many cones does it take to fill that cylinder? 1, 2, 3. So the pyramid-cone volume conjecture. If B is the area of the base of a pyramid or cone, and H is the height of that solid, then what is the formula for the volume? Remember, if it was a rectangular prism, it would be the base times the height. But the pyramid was 1/3 the volume of the prism. So 1/3 base times height. The cone was also 1/3 of the cylinder. So 1/3 base times height. Example 1. Find the volume of a regular hexagonal pyramid with a height of 8 centimeters. Each side of its base is 6 centimeters. So we know that the volume is 1/3 the area of the base times the height. Now we have to work on the area of the base. Let's look at a regular hexagon. Each side is 6. Do you remember our formula for the area of a base? I may not remember exactly what it is with that apothem, but I do know that all of these triangles in a hexagon are equilateral triangles. So they're all 60 degrees. And I can look and know I have to find the area of one of these and then multiply it by 6 of them. So one of these triangles is going to be 1/2. The base of the triangle is 6 times the height. That's that apothem. So if this across is 6 and this is 6, if I take just this little one, that's a 30, 60, 90 triangle. I still have 60 here, but I have half up at the top. So half of that 60 is 30. And I know that that was a 90-degree angle. So this little part is 3. This long part is 6. What does that make the apothem? This is x, 2x. The apothem would be x squared of 3. 3 is our x, so the apothem would be 3 square roots of 3. So I can use that as my height of the triangle. Sorry, I said 3 and I wrote 2. It's 3 square roots of 3. So 1/2 times 6 times 3 square roots of 3. That would be one of those triangles. And I have 6 of them for the base, so I need another 6 in here. Multiplying all this together, I get 54 square roots of 3. I'm going to put that in for my base right here. So my volume is 1/3, 54 square roots of 3, and then times my height. The height was 8 centimeters. That was up and down on the pyramid. Multiplying all that together, I get 144 square roots of 3, which I could estimate as 249.4. This is volume, so I'm in cubic centimeters. Example 2. A cone has a volume of 24 pi inches cubed and a height of 8 inches. What is the radius of the base? Here's my cone. I know this height is 8 inches. I know the volume is 24 pi inches cubed. What is my radius? My volume formula for a cone is 1/3 area of the base times the height. The area of the base is the area of a circle. So 1/3 pi r squared times the height. Now I'm going to plug in what I know and set it equal to 24 pi. So 24 pi is equal to 1/3 pi. I do not know my radius, but I do know my height. My height was 8 inches. Since everything's multiplied together, I can divide by pi on both sides. Now, I wouldn't ever divide by a variable, but pi is a number, 3.14. So dividing by pi cancels pi on both sides. Now I have 24 is equal to, I'm going to combine the 8 and the 1/3 as 8/3 r squared. Now to get rid of the 8/3, I'm going to multiply by 3/8 on both sides. And that will make that 1. So I'll just have r squared. On this side, it will make it 9. Hopefully you see this, r squared. I'm going to square root both sides. So 3 is equal to r. So my radius was 3 inches.